AOPS Volume 1, the Basics, number 106. When the number n is written in base b, its representation is the two-digit number ab, where a is equal to b minus 2 and b is equal to 2. What is the representation of n in base b minus 1? So for this question, we just need to first write down its given information for us. It tells us that number n is written in base b. Its representation is a is equal to b minus 2, b is equal to 2, meaning that in the form of AB, how are we supposed to write this in base B? Well, in base B, it will be equal to A times B plus B times B to the 0 power. So with this representation, we're given that A is equal to B minus 2. So B minus 2 times B plus B, which is equal to 2 times 1. And now we have to transform this form to be a form where it's written in terms of A times b minus 1 to the first power or second power or whatever power. Because we can transform a number in a base to another base by rewriting it into a format that relates to the definition of changing bases. For example, 241 can be written as 2 times 10 to the second power plus 4 times 10 plus 1. Can we rewrite this equation somehow in terms of 2 to the second power some constant times 2 to the second power plus b times 2 plus c times 2 to the 0 power? Can we write it in some form? Well, that is the same process that we're going to use to change it to, instead of base 2, base b minus 1. So first I'm going to expand this to get b squared minus 2b plus 2. And since I know I'm trying to rewrite this into the form of b minus 1, I know that b minus 1 squared from basic memory, that b squared minus 2b plus 1 is equal to this quantity right here. So this quantity, b minus 1 squared, is just one off than this quantity. So we can rewrite this to be equal to b minus 1 squared plus 1, correct? Well, what can we rewrite this to be equal to? This is equal to 1 times b minus 1 squared plus 0 times b minus 1 to the first power plus 1 times b minus 1 to the 0 power. And by rewriting this number in base b, I just rewritten it in terms of base b minus 1 so that I obtain this format. And since I obtained this format, how do we read this number when we write this in base 10? Well, we read this to be equal to the coefficients of the powers of 10, which is 241. Likewise, for this one, we read the coefficients to be equal to 101 base b minus 1. So you see the ingenuity behind the change of bases. And this type of problem solving ability takes time and endurance to enhance. But nonetheless, the answer to this question is 101 base b minus 1.